So you can start in a minute's time, Harrison. If we don't see anybody else, then yes, these sessions are recorded and it can be used for future reference for all the learners across the board. So yeah.
Perfect.
Thank you. The stage is all yours.
All right, well, welcome, Greg. Welcome, Wendy. You two are the ones that I have here. So in an audience of this size, feel free and absolutely please come off mute and communicate with me. Let me know if there are topics that I'm going to introduce that you want to go deeper into. My name is Harrison Sherwin. I am based out of Denver, Colorado in the United States. I was asked to do just kind of a basic introduction to Amazon VPC. In my day job, I am a technical trainer. I will teach both AWS internal audiences, external AWS customers, and a whole host of different people all about different AWS products. I teach a wide variety of our courses from the cloud practitioner level, associate level, professional level, and specialist level. So I'm kind of all over that. The most relevant certification that I have for this particular session of us is I am actually one of our advanced networking specialists. So there is not going to be any of these networking topics that I feel uncomfortable going into as we are discussing. So ask me anything you want. I don't actually have really any slides prepared past these two. And the reason for that is I find, especially within an hour, networking is better taught through actually looking at the platform and through whiteboarding. So I have a rough list of topics here that I want to make sure we cover. If we want to go deeper, I have kind of a list of further topics. But that's really all I've got from a slideware perspective. So I'm actually going to jump off that and move some things onto my screen here. And make this go away. Perfect. Don't need that anymore. What we want is this. So Amazon VPC is the networking stuff that makes all of AWS server-based components possible and allows components of other services to intercommunicate. Just like how in your home, if you have a phone, it's probably connecting to your local network or to a cell phone network. How all of that stuff talks is computer networking. What we use to make that stuff work and allow our virtual servers, our EC2 instances, our databases to intercommunicate is Amazon VPC, our virtual private cloud service. When we start with VPC, I'm going to go here and just launch the VPC wizard. We have a few different options for ourselves. The VPC itself exists on a regional level. It spans across all of our availability zones, our collections of data centers within an AWS region. So I'm currently in Northern Virginia. You can use the wizard to make things easier for ourselves. And what we'll find when we go into the wizard is we have a couple different choices. The first two is between a VPC and subnets. Whether we can have a single public subnet or a combination of public and private subnets. Can either of you tell me why I would be interested in multiple subnets?
You'd like to keep certain things separate from, certain users or certain applications that only got access to maybe certain databases, stuff like that. So you'd want private subnet for maybe keeping the backend database and the public subnet be forward-facing.
Absolutely. Isolation is a big component of it. Our customers will typically isolate their network resources in one of three ways. They'll just put it in different VPCs altogether. Might have stepped out there for a moment. Hopefully my network right now is working just fine. Let me turn off my video to help out a little bit with that. So that's where this story of using VPC begins, is we want to go use a VPC and we want to use a subnet. So I introduced the wizard here to show you don't have to do all of this on your own if you want. But what I'm actually going to do is I'm going to jump over to the VPCs that I already have. And we're going to create a new one. We're just going to call this, let's go with restart VPC. The name purely for you. But when we are then configuring a VPC, we need what we call a CIDR block. CIDR stands for classless interdomain routing. The CIDR block determines what IP addresses we are allowed to use within the network that we are creating. So you can see an example here of 10.0.0.0/24. If this concept is very new to you, there is a third-party tool that I will often introduce called CIDR.xyz, and it allows us to explore what does that CIDR block mean. So let's put the one in there that we just looked at, 10.0.0.0/24. So what this is illustrating for us is that the first 24 bits, the first 24 ones and zeros of our IP address, those aren't going to change. That is my network definition. It's these last 8 bits that are allowed to change. An IPv4 address is made of 32 bits. So the first 24 with that /24, those aren't going to be changing. But the last 8, those are what's going to change through the range of my network. You can see if we use the first usable IP, it actually starts at 1 and not a 0. That's because the .0 represents the network itself. And that address, that first address in our network, is not typically going to be used by an EC2 instance, a virtual server, a resource within our network. We also don't tend to use the last one, the .255. We don't tend to use the .255 because that's called the broadcast address. It's used to communicate with all of the different resources within a network. We don't actually support that functionality within AWS, though. So if you want to explore more on CIDR addressing, what a CIDR block is, what the ranges are, I would encourage you to use this tool to go explore that. But that is how we end up with what a CIDR block is. When we are defining a VPC, those are the two things we have to have. We have to have a region. We have to have a CIDR block. Even the name is optional. We can make a VPC without a name entirely. Another optional thing we have in here is called IPv6, which is a more advanced version of IP addressing, how we assign basically addresses like in a postal system to communicate with our virtual servers. The short version between them is IPv4 version 4, supports about 4.3 billion addresses, and we have hit that cap and beyond. IPv6 is designed to support 340 decillion. It's a whole lot of zeros. So we're pretty good with V6. We're just slowly merging all the internet and all these other things over to that kind of system. What IPv6, though, is probably beyond the scope of what we want to talk about here. So we click Create. When we click Create, a lot of things are going to happen automatically, but ultimately this VPC so far, completely useless. And the reason it's useless is there's nothing that can use this VPC yet because it doesn't have any subnets in it. So we're going to go through and we're going to go put a subnet in there. I'm going to click Create, and I'm going to select my Restart VPC. Now I can pick a subnet name, so we might do Restart Subnet 1. We pick an availability zone. Subnets are specific to an availability zone within an AWS region. Or we can let the algorithms pick for us. We can let AWS decide. And then we also need a CIDR block. Now, this CIDR block is designed to be a smaller component of the CIDR block of our VPC. So we picked 10.0.0.0/24 before. So what we might pick here would be 10.0.0.0/ let's go with 25. One more. So it'll actually be half of the range of what we selected before. We could add more if we want. I'm just going to go with create for now. And we have a subnet. Subnets and VPCs are the core concept of what the Amazon VPC service is. It gets confusing because the name of one of the things you make is a VPC and the name of the service is VPC. So the VPC is regional, the subnets are by availability zone. So I'm actually going to skip ahead a bit. I've shown you some of the basics of creation. I'm going to skip ahead to something that's already been done. And what I have here is I have a couple EC2 instances that already exist within a VPC. It's called demo main VPC, and they exist in subnets. So if we actually go to the networking tab of one of these instances, we'll see what's been provided to it. You can see the VPC, the subnet right there. I have an IP address that has been allocated to me by the VPC, specifically by the subnet that I'm in of the VPC. You can see which availability zone it's in here as well. So we connect these EC2 instances to the VPC through something we call an elastic network interface. It's like a virtual networking card. And that is what allows us to communicate on this network that we are building. So let's take a look at this address, 10.0.0.123. And I have another instance over here that we're going to go ahead and look at. So this instance is in an availability zone in US East 1A, the first availability zone in Northern Virginia, and the 123 is in another availability zone, which means they must inherently be in different subnets. When they're in different subnets, but in the same VPC, it's actually really easy for me to communicate between them. I'm actually going to clear that out. And I'm going to do a networking tool called ping. Ping lets me just say, hey, are you there, to some other networking resource. And this allows currently is showing that my EC2 instance in US East 1A is allowed to talk to my instance in US East 1B. I said to ping its specific IP address. I'm going to go ahead and stop that. Now, an important part here is I'm in different subnets. How did those subnets know to talk to each other? That is done through routing. So if we actually look at the subnet for the instance that we're logged into, this one at the top, I'm going to bring that subnet up on my screen. And the key thing I want to show you that is attached to the subnet is called the route table. The route table tells me when I want to send network traffic out of my server, out of my instance, where does it go? Depending on what I want to communicate with. And that is what is defined in a route table. A route table contains routes. All VPCs have a default route called local. Local is defined as the CIDR block of the VPC itself. So this rule that I'm illustrating here says if you're trying to talk to an IP address in this IP range, stay local. Stay inside of the VPC. Don't go anywhere else. Okay. So we got routes inside route tables that tell us where do I go? What do I do? How do I get there? Part of the other thing that has to happen in place here is security. There are a lot of different places to apply network security within AWS. I'm only going to talk about two in this session. The first is the idea of what we call a network access control list, or a network ACL. And this is a firewall that exists at the boundary of our subnets. It is going to look at all traffic, everything I want to communicate with, as it enters or leaves the subnet. Every time that happens, it's going to look at that and says, am I going to allow you to enter or exit my subnet? And this is determined through rules. Rules are grouped into two categories, inbound and outbound. So you can first see inbound rules on my list. So I have an inbound rule here that says I'm going to allow all traffic of all protocol types across all ports for all IP addresses. I'm going to allow all traffic. That's what this 0.0.0.0/0 means. It means all IP addresses. I'm going to allow that. Now, you'll notice there's another rule right below that, and it's a star. Network access control lists evaluate rules through a priority. So we look at all the rules in numerical order. If there was a rule 1, 2, and 3, we would look at rule 1, and then rule 2, and then rule 3. And what we're looking for is we're looking for the first rule that matches the traffic we're sending out. And if we don't find a rule, we go to the star, the wildcard, the catch-all. And that will evaluate my traffic last. So rule 100 here is designed to catch all traffic before it gets to my wildcard. Inbound rules evaluate traffic as they going to enter my subnet. This is as opposed to outbound rules that are going to evaluate my traffic as it exits the subnet. So if I am trying to send a network traffic, like a ping, between two different subnets, I'm going to go through one subnet's outbound rules and then another subnet's inbound rules. So I can actually illustrate a little bit about how that works here. So what we're going to do is we're going to go back to my thing and we're going to make my ping go again. And I'm actually going to drag that off to the side here and bring my other one up here. So now we can see my ping, and I'll be able to edit my rules on the right. So the ping is still going. It's still saying, all right, here's another one, here's another one, here's another one. You can see that because the ICMP sequence right in the middle of that is increasing. So what I'm going to do is I'm going to jump in here, and I am going to edit these rules. I need to do that by going to the access control list itself, checking it off. Here we go. Inbound rules. We're going to click edit, and we're going to switch this to a deny, meaning now all traffic is blocked. And as soon as I clicked save, that stopped counting up because the pings are no longer being successful. They're no longer allowed to flow. One of the subnets is no longer allowing them there. But if I jump back in here, edit the rules again, and allow the traffic, and click save, now they start going again. You can see there's a jump between 62 and 85 there. Now they are working. 62 and 85 were the pings that weren't allowed to pass. So this is one of the firewall rules in place within are VPCs, network access control lists, or network ACLs. Any questions so far?
Harrison, I do have a question.
Go ahead.
Just now, you did all of that without having to shut anything down, without having to stop the instance or anything.
Yep.
There are some cases where you have, I've been studying for the solutions architect exam, and they ask you cases where you have to shut things down. I'm totally confused of when you need to stop an instance or shut it down to make some kind of change. Or can you think of like an example of that?
So usually that decision is actually for outside of the VPC stuff in general. There are a couple components there where you do have to shut it down. And those are going to tend to be things that require communication between the EC2 instance's operating system and the VPC service. So one example of that is if I want to change the IP address of an EC2 instance, that will sometimes require a reboot. Or if I want to change its domain name, like Amazon.com, that's a domain name. Changes that get inside of the EC2 instance, depending on the operating system, depending on the software, those can require reboots. You are absolutely correct. But the changes I'm making here, as an example, are not affecting the operating system at all. This is about the network traffic after it comes out of the operating system and as it goes out of the virtual server. This is about like your Wi-Fi router. If I unplug your Wi-Fi router at home, your computer still works fine, but it can't get to the internet. I plug it back in, network connection should come right back without you having to do anything on your laptop or on your desktop.
Okay, that makes it clear.
Perfect. Any other questions? All right. Network access control lists are an example of what we call a stateless firewall. And this means they don't remember anything about past traffic. And I've illustrated to you a little bit about how that works. It doesn't matter what I did in the rules. Every piece of network traffic is evaluated at that exact moment. I'm going to show you an example of a different kind of firewall now. And that firewall is called a security group. Security groups are firewalls that exist at the instance boundary. So let's back up for a moment. Network access control lists exist at the subnet boundary. So would a network access control list evaluate traffic as it goes between two instances in the same subnet? You can come off mute or tell me in chat. Or guess. I like guesses too. Guesses are fine.
I'd say no. I'd say it wouldn't.
Yeah, that's exactly correct. Thank you, Greg. Network access control lists don't evaluate traffic between two instances in the same subnet. Security groups do, because security groups exist at the instance boundary. They evaluate all traffic as it enters and leaves that virtual server. As soon as it gets to the VPC stuff, it's already been evaluated by the security group. So this is a different place where we can apply these rules. And our customers will often use a combination of the two. So if I have rules from the government that say I have to block all traffic of a certain type no matter what, we'll apply that at the network access control list. But if I just want to be secure and make sure that the database can only accept traffic from a couple instances and only under certain conditions, I'll tend to apply that at the security group level. Can it work at both levels? Yes, ultimately it can. But the examples I just gave are more representative of what we see in real life and more representative of the best practices we teach in the courses. So in my security group, and I can have security groups applied to multiple instances. And this security group I'm going to show you in a moment is actually applied to both of the instances that we have talking right now. I have some inbound rules. I have two that allow a website to be shown, and I have one here for ICMP traffic. That is what allows pings to work, the Internet Control Messaging Protocol. You don't need to remember that. Watch what happens when I delete this rule. I'm going to completely delete it and click Save. Hey, wait a minute. Why is my network's traffic still going? Anybody know the answer to that one? Security groups are what we call, go ahead. Security groups are what we call stateful, meaning they can actually remember if we allowed traffic one way and inherently allow it back the other way without an explicit rule, because these security groups also have inbound and outbound rules. And my outbound rule here says I'm going to allow all traffic to all sources. So one of these instances is remembering, oh, you allowed that traffic out, so I'm going to allow the response to come back. All right. And it works the other way because the other instance is using the same security group. So these pings are flowing right now, but watch what happens when I stop the ping, let it sit for a second, and then start it again. Oh, now it's not working. You don't see any pings happening because I've stopped that connection, I've cut that communication, and then started it again. And now we know, oh, I don't have to allow a response back because I haven't done this before. I'm not actively doing that right now. But if I go back into here, edit my inbound rules, add myself a rule, change this back to my type of ICMP, I can allow that traffic to go. I could do that for anywhere, but that's not actually what I'm going to do. The reason I'm going to do that is I'm going to adopt a thing called the principle of least privilege. I am only going to allow this traffic to work where I need it to come from. And where I'm expecting this traffic is from my other instances using this security group. So I'm going to say you're allowed to accept all ICMP traffic, but only if it comes from this same security group. So I'm going to click Save. And now the pings work. So network access control lists are stateless. They don't care about the past at all. And they apply rules to traffic as they enter or leave subnets. Security groups evaluate traffic as they enter or leave instances and do care about the past. The other thing with security groups is you can have up to 5 different security groups attached to the same EC2 instance. So far we've covered basics on VPCs, subnets, route tables, network access control lists, and security groups. And I've gone through it pretty quickly. I went a little bit faster after hearing y'all are around the CPE level. But are there any questions on any of that so far? All right. So we're going to stop talking internally now. And I'm going to turn off this ping. I'm going to ping something else that I don't own. And it might surprise you, but I do not own Amazon.com. But I'm going to go ahead and ping that. And that's in an entirely different network entirely. It's probably in a VPC, but it's in a different network entirely. So how can I talk with it? Well, that story starts with the route tables again. So if we go look at the route table that I'm using here, it's going to be this one. I have another route that looks at all IPv4 traffic right here. 0.0.0.0/0. And it is designed to go to a NAT gateway. Whenever we are using a website on the internet, they are using what we call public IP addresses, meaning that they are allowed to accept traffic across the internet. And like any good website, they're going to do that no matter who you are. You might have to log in to get to the good stuff, but they're going to do that no matter who you are. We call that unsolicited traffic. You didn't ask for it. It would be a really bad idea if anyone on the internet could log into my laptop or your cell phone or your TV unsolicited and get in there and just mess around with things. So instead, we have a difference between public IPs and private IPs. You don't really have to memorize the list, but our private IPs will tend to begin with numbers like 10, 172, or 192. I used tens in my example. And the reason we do that is something called NAT, or Network Address Translation. And it was come up with a long time ago when we started running out of IP addresses on the internet to begin with. And we needed a way to make sure that we had a space that everyone could use on their internal networks, but that didn't get made publicly available. And that's the idea that NAT enables. It allows us to translate incoming traffic on public IPs to private IPs. You have at least one public IP on your home router if you're accessing the internet. You may not know what it is, and that's perfectly fine. It's usually automatically assigned to you, and it might change and you'll never notice. But you've always got at least one. But you might have 10 different internet-connected devices in your home using that one connection to the internet. And that's part of what allows NAT to work. NAT will remember John's cell phone requested this website, but Cindy's database requested this patch for her operating system. And NAT can keep track of who's asking for what coming into one entry point. So that is what a NAT gateway is. And the reason I am using a NAT gateway here is my NAT gateway allows me to be more secure. Means that somebody randomly on the internet can't get into my little demo instance here and mess around with it because it doesn't have a public IP address. Now, what does have a public IP address is the NAT instance itself. It's using 52.2.4.81. So it could receive unsolicited traffic, but it knows it's not going to pass that along to somebody who didn't ask for it. So it's a good security measure there. But so far, I'm not at the internet. I haven't figured out yet how I got my VPC to connect to the internet. All I've done is I've connected really my instance to the NAT gateway. My NAT gateway here is actually in a different subnet. And because it's in a different subnet, it's going to have a different route table associated with it. And this route table has a different set of rules. It has also a 0.0.0.0, but instead of sending traffic to a NAT instance, this is sending it to an internet gateway. And the internet gateway is attached to my VPC. And its entire job is to be the connection between the VPC and all things in it to the internet. So let me bring this up here. And I'm actually going to do this. So we start with my EC2 instance. Between my EC2 instance and everything else, we have a security group. And I'll put these in boxes in a moment. The security group then is with the subnet. Then we have our network ACL. And then we have our VPC. And I'm going to draw a couple other things here that I'll explain in a moment. So I'm just getting the text out of the way here. Okay. Now let's box that up. Our EC2 instance exists. And as traffic enters or leaves the EC2 instance, it has to go through the security group. The EC2 instance is created within a private subnet. It's called a private subnet because it doesn't have a direct connection to the internet. The network ACL is attached to the private subnet and evaluates all traffic as it goes through. So if I'm sending traffic out to the internet, it's going to start here with my EC2 instance, go through my security group, through my public subnet, and then to my network access control list. And my private subnet also has a route table, which I didn't put on the screen, that's determining where it should go. Now, if I want to go out to the internet, I need to go to my other NAT gateway. That's where I told in my route table the traffic needed to come from. So my NAT gateway needs to make sure the traffic gets through a network access control list that is attached to the subnet of the NAT gateway. The NAT gateway has its own attached security group, and it is part of the public subnet. So that traffic's going through all of this to my NAT gateway. And now my NAT gateway needs to get that out to the internet. So everything we've just constructed, let me fix that. Everything we've just constructed is within a VPC. All of it. And attached to that VPC is my internet gateway. So as traffic is going to come back, the NAT gateway goes, oh, you want to send something to the internet? Well, I have to go back through the security group, back through the subnet, back through the network access control list, and then I go to the internet gateway, and then we get all the way out to the internet. And if I wanted to send internet traffic as a response back to the EC2 instance, it would have to go back through the whole way again. Any questions on that? I'll actually put it back up on the screen there. Let's see if I can do that. Not easily, apparently. Here. There's a sadder way. Any questions on that architecture? This is the basics of how we communicate with the internet, with any AWS resource we make that's going to be based in EC2, which will include things like our databases. Some services that are serverless use something different to this, but this is VPC networking basics. This is about the first hour and a half or so, shortened a little bit, of our architecting on AWS courses networking module, just without any of the slides, because I can't show that to you. All right. So those are the topics I plan to go to in depth within our hour of time together. I wanted to then introduce some concepts of topics that go a little bit beyond that. So first, there are other places we can connect our VPCs to besides the internet. One common place that we would connect them to is to our own private network, typically within our business. So we're going to operate our own network within our own buildings, and we tend to want to connect our AWS resources back to that building. This can be done in two ways, and those two ways can be combined. And that is done through the idea of a VPN, or a virtual private network. Normally, when you send traffic across the internet, most of that information could be read by anybody. It'll say where you're trying to go, how you're trying to get there, and where it came from. Sometimes the actual data you're requesting might not be easy to read, but the to and from address typically is going to be. And that's not always the most secure method. So what a virtual private network does is it lets two different private networks agree on a secret code. It's called encryption. And the secret code is going to jumble up all of that data that they're communicating back and forth to each other, making the connection across the internet much, much more secure than it would be normally. VPNs can be configured with VPCs through a tool called a virtual private gateway. The other way that we tend to connect to our on-premises environments is called AWS Direct Connect. AWS Direct Connect works with VPCs so that instead of sending your traffic to your own network across the internet, you send it across private network connections. All the internet is a bunch of glass and copper under the ground, under the sea, sometimes above in the air, sometimes wireless components, owned by a ton of different companies that figure out how to route stuff between them. It's complicated, it can be fragile, and not all of those businesses are most interested in getting your traffic to where it wants to go as fast as possible. So instead, you can work with AWS and our partners through what we call direct connect edge locations. And we build out private cabling and private fiber optics that no one else is using between your site to the direct connect edge location. And the direct connect edge location also has a private connection to Amazon's global network that we maintain, and we route traffic around for our purposes and for the purposes of our customers using Direct Connect. So VPNs and Direct Connect are two of the ways that we can get to our on-premises networks. The other topic we can quickly go over at a high level is how we connect to other AWS things with our VPC. And the first of those is called a VPC endpoint. VPC endpoints are used to direct our traffic from other AWS services that aren't necessarily in VPCs for you for your EC2 instances. So if we go back to my route table that I was using, there were two other routes you might have seen in there. And let me just maximize this. Blow it up a little bit. That's an extra route. And the short version of what this does is it's going to say any traffic that you are trying to send, in this case, to the Amazon S3 service, our simple storage service, we're not going to send that across the internet. We are instead going to send that directly to the S3 service. If I didn't have this, and my EC2 instance wanted to do something with the S3 service, it would have to go across the internet. Two reasons why we don't want to do that. One, it's less secure. Two, it's more expensive. It increases our data transfer charges. So instead, we can write these route tables to point to VPC endpoints that say, if you have traffic that is trying to go to another AWS service, go through this path instead. Stay off the internet. Stay internal to the AWS region. And sometimes we want to talk to other VPCs. Might be VPCs we have that are just separate. It might be VPCs in another AWS account. Or it might be VPCs in another AWS region. We can connect two of those VPCs under any of those circumstances through what we call VPC peering, which just establishes a connection between two of them. We put another entry into the route table to say any traffic intended for this IP address range of the other VPC go here instead. And the final topic I think we'll cover before we'll turn it over to just Q&A about really anything you'll want, it's the idea of a transit gateway. It works actually pretty similarly to a VPC. And let me bring this back up here. So let me get rid of this and draw this out. Do blue, do that. Okay, so VPC peering does something like that, and only that. And the line connecting them is the peering connection itself. Okay. So if I wanted to bring a third VPC in, I don't just have to build one VPC peering connection. I actually have to build in two more, one to there and one to there. The reason I have to do that is for security reasons. We don't support something called VPC peering. So this can get pretty complicated for our customers when they start bringing in 10, 20 different VPCs in different accounts and in different regions. So if they want something to make that complexity a little bit easier, they use something called the transit gateway. So the transit gateway is going to act as a hub in the middle of all of those different VPCs. So we're going to represent my VPCs as my blue circles. We're bringing a couple of them. And we use our transit gateway, or TGW. And we connect, or attach is the word we use, all the VPCs to the transit gateway. And the transit gateway then has rules to say, how does traffic flow through me? It's really acting as a hub between all these different VPCs. So I can connect just one VPC into these transit gateways through just one connection. And that VPC now has the option to communicate with all of the other things attached to the transit gateway. And we don't just have to attach VPCs to the transit gateway. We could attach other transit gateways, and we can attach our VPN connections as well, and AWS Direct Connect connections. Just a little bit of an illustration there. VPC is a massive topic. I've really started with the basics. I went in pretty deep. I've introduced some of the more advanced topics, but there is a lot. Within our Solutions Architect Eyeing on AWS class, we talk about VPCs and provide a lab and probably spend 4 to 5 hours on that networking topic. So don't be daunted that he introduced so many different concepts. There is a lot there, but a lot of the things I talked about are at that associate level. And the associate exams are pretty well defined in what topics you need to know within networking and which ones you don't. There are people whose entire lives are dedicated to just networking. They're called networking engineers. What I've given you is the tools to be successful with some foundational level of AWS usage, and everything else is just designed to either make you more secure or to accommodate more complicated infrastructures. We've got about 5 minutes of time left. Any questions you have? Nothing is too complicated or too obscure. I'm happy to answer it. I'm glad things are a lot clearer for you, Wendy. I'm very happy to hear that. It is definitely networking in general, and especially the AWS VPCs, are really hard to get if you just sit down and try to read a book or try to read the documentation or even go figure it out for yourself. It is my opinion that you really need a tour guide through networking, at least at the beginning. All right, I don't hear any questions. So with that, I'll pass it back to you, Ragharuja.
Yep. Thanks, Harrison. That was a great session on VPC. Pretty clear, crisp. So I really enjoyed it. So yeah,
Glad to hear it. Thank you for the feedback.
Yeah, absolutely. Looks like nobody has questions on any further questions. So yeah, we should be good to go from here.
Thank you, Harrison. That was wonderful.
My absolute pleasure.
Yep. Thanks everyone for joining, and thanks, Harrison. And we'll see you in the next session.
Thank you very much. You have been brilliant. Have a good evening.
Thank you.
Good day.
Yep.
And
Thanks.
I'm going to put my email in chat quickly if anybody wants it.
Okay, thank you. Hash. Hashawi at Amazon.com.
All right. In that case, I'm going to go ahead and drop off. Have a good night, everyone.
All right.
You
Thanks. You
too.
too.
Thank you.
Yep.
Peace be with you.
Thanks. Bye-bye.
Bye.